I've been watching Black Mirror, so I'm like all of my technology. Yeah, we can talk about that at some point. All right. So, are we good? Over here? All right. What we're going to focus on today is the free response. And free response is going to be a place where the second fundamental theorem of calculus pops up. And it's going to pop up a lot, sometimes in places that you don't expect. The second fundamental theorem of calculus says this: the derivative of the integral of a function from a constant to a variable, what happens? There's only one thing that happens here. It's the original function, but with the new variable. That's it. That is it. As long as there's a constant on the bottom and the variable on the top, and you're taking the derivative in the integral. And we've seen some times where you don't have the derivative, which means if you don't have the derivative, you can't do this thing. Then there's the extended version. The extended version says the derivative of the integral of a function from a constant to something more complicated is going to be your original function with the new function plugged in times the derivative. And we've never done like a formal proof of this, but we did look at a couple of examples. We've seen how this happens. For some of you, it might still be a mathematical mystery. But I will tell you, when it comes to the AP exam in 83 days from now, I know I need to update the number, you should expect to see a question like this on the free response part of your exam. Which means that on Friday, on this unit test, you should expect to see a problem like this on the exam. Which means for the next 25 minutes, you want to make the absolute most that you can out of the time that you have. I'm going to put 8 minutes on the clock. The goal for you all in the next 8 minutes is to read through this problem, make sure you understand what's going on, and get through A, B, and C. 8 minutes from now, I'm going to put my solutions up there. You can see how well you did. We'll go from there, and then you'll have a decision to make if you want to keep working with me or go solo. We'll talk in 8 minutes. Marilyn.
Bless you.
Everybody's working on A, B, and C. Yeah, huh? Alright, all the A-B friends are here.
Yeah.
What you change?
Oh, the GL.
So basically, if you want to connect up another party. Because of their problem.
Like, did you just find here? -6 to -2?
Oh, you're right. Yeah. So just because
You can also
because it's going from -2 to x, so that's the second.
Wait.
So basically, we're finding like the theorems for from -6 to 2.
Yeah, would that be like the, what's it called, the area? Yeah.
Oh, okay. So you're looking for G, so then you put X on top. So then you base this, right? This is the same thing
Never mind.
for the area.
What you mean?
So
Oh, never mind. You have to do by half.
yeah, so this equals
How do you know that you're going from, put it, so you put the negative 6 and negative 2?
so when you find the area, 1/2 times base.
Because negative 6 is like, it's,
Oh, that's in G, yeah.
está más pequeño que negative 2. Different. You can also go the other way around. But you have to add a negative. I can say what you get.
What's the area of the circle?
Pi r squared. Semicircle, so it's
What would it be? What would it be?
oh no.
Yeah, I was Is it 10? She put some letters like tilted at the very end. It is 20. It's 10. It's 10. It's good. We don't have one day.
If you are moving in a good direction, and for G of negative 6, you have negative 10. And G of 3, you get 2 pi minus 1. You get 1 point each. How many guys just picked up 2 points? Okay, I am really worried that I'm seeing 2 people out of 27. If you are not getting those answers, you need to be having some conversations. Keep going. Yes, sir.
Well, you want to be careful because first of all, you don't want to just show me. Oh, okay, so you show me some work. Right. To find G prime of 0, but why is this? Okay, but you're going to want to write that out. G prime means you're finding the derivative of that integral. Yeah.
How come for G of negative 6 is negative?
G of negative 6. You're doing the integral from negative 6 to negative 2.
So I think the one
From negative 2 to negative 6. Right, you're going from negative 2 to negative 6. Here's negative 2 on the x-axis. Here's negative 6. You're going backwards. Right, when you go right to left, the area has the opposite value.
I thought it was only supposed to be negative if it was below the.
One reason why area winds up being negative is if you're below the x-axis. But if you're going in a right to left versus left to right, it's always the opposite value. Right, so like right in the beginning, Karina, my choice was G of negative 6. If I just write it the way it's supposed to be, it's the integral from negative 2 to negative 6. But that's telling me go from negative 2 to negative 6. So I've got to switch my limits of integration, which introduces the negative sign.
So if I figured out like G
I think it's here.
We're using, so we're using that heuristic way to find the derivative. Finding the derivative with G.
I mean, I figured it out because I forgot about like 1 to 3 x 7 to 2. So it's like, yeah. 1/2 is 4, then 5.
Right.
Why would you just replace it?
Because that's the rule.
Yeah, so you can find the area of this triangle. Like the basis for the height is 5 divided by 2.
Okay, I'm not seeing nearly enough progress on G prime of 0 and G double prime of 0 to make this time worth it. So, let's do this. All right, so in part B, if you're going to find g prime of 0, the thing you're going to remember is this is a two-step process. It's two parts. The first part is you have to find g prime of x. You have to find the function first, then do the evaluation. Well, how do I find g prime? And unfortunately, there's a g missing there. G is the integral, so g prime is the derivative of the integral from -2 to x of f of t dt. You have to show this at least one time in your thoughts. Well, what's g prime then? If this is the derivative of the integral of the function? F, oh, careful. F of x. You're finding the function first. If somebody in the back can turn that up. G prime of x is the derivative of g, which is f. Okay, now get me to g prime of 0, and I saw in a couple of papers, oh, well, g prime of 0 is f of 0. But if you haven't made this link, then this statement gets you no credit. Well, what's f of 0? F of 0 is 2. Congratulations, that gets you the first point. Sometimes they're going to give you another point for establishing the connection between g prime and f, but you have to show it. You have to have some reason. Well, g double prime of 0 is also two steps. First, find g double prime of x. If g prime is equal to f, then g double prime
is equal to f prime.
has to be equal to f prime of x. You have to show the function connection first. Now, g double prime of 0. Well, that's f double prime of, whoa, f1 prime. F prime of 0. What's f prime of 0? Wait, what's f prime of 0? 0. Why?
Saddle point.
Whoa, I'm hearing all sorts of bad vocab here.
And relative math.
There is no cusp point at 0.
This is a cusp.
That's not a saddle point. What's happening here?
Increasing?
You have, well, what's f prime? This is f. F prime means slope. What's the slope there? 0. You have a horizontal tangent line there. F prime of 0 is 0, would be the last point. Quite honestly, A and B are the kinds of questions I would expect everyone to score a whole lot of points. Henry?
So wait, so why did you write the integral there and then go from g prime 0 equals f 0? Like,
So, you're asking about this guy here?
yeah.
This is what it is initially connecting the function. Like, we're talking about g prime, but g prime is the derivative of the integral that I gave you in the beginning. Second fundamental theorem of calculus says the derivative of the integral of the function from a constant to a variable is just the old function with the new variable. You have to show this connection first.
So you don't find the area when you do that?
No, because that's, you needed to find the area in part A because g of -6 said, okay, g of -6 is the integral from -2 to -6 of f of t dt, and a definite integral is area. It's over here we're using the second fundamental theorem of calculus. All right, we're moving on. All right, part C. Find all values of x in the open interval for which the graph of g has a horizontal tangent line. Have a conversation with somebody near you. What does that even mean? What does that mean that g has a horizontal tangent line?
Does it mean that like there's a 0 or 2 or 5?
Yeah, it turns off the glass. G has a horizontal tangent line. Can you guys show me what a horizontal tangent line looks like? I just want to check in on vocab here. Horizontal tangent line looks like this. What do we know? Slope of what is 0?
G.
G has a horizontal tangent line. Means that G prime is equal to 0, right? Because G prime is slope. That's a horizontal tangent line. Well, where is G prime going to be equal to 0?
When F
Where
prime-
F is equal to 0. That's why it was so important that earlier we made that connection. So this means that F is equal to 0. Oh gosh, where's F equal to 0?
X equals -6, -2.
Negative 6, negative 2, and x equals 2. And that's mostly good, but not 100% good. I like it, but I don't love it. Someone's going to write something like this on Friday, and I cannot give you all the points. Jackie sees it, Karina maybe sees it, Gonzalez thinks he sees it. Why am I not going to give you all the credit? I cannot. Mr. Trier at North Side would not. What's the issue here, Jackie?
It's asking from the interval of -6 to no. Wait, no, it was supposed to be because we're not stating which one has a local maximum.
Well, first of all, we're not finished. We're not finished. There is a problem here. Daisy, what's the problem?
X equals -2 is a cusp point?
X equals -2 is a cusp point. I agree, but that's not the problem. That's not the problem. I'm glad we're having this conversation because I would hope this is a little bit clearer. Rubio.
-6 is not in the interval.
It's not, but doesn't the interval say from -6 to 3? You are not allowed to include the -6. You cannot include the -6 in your analysis. You want to throw it out. All right, everybody okay?
Yeah.
All right, so now I need to make some decisions. Do I have a relative max or a relative min at -2?
Neither.
Neither. This is neither. And my write-up would be something like G prime does not change sign at x equals -2, which implies G has neither a max nor min at -2. What about at x equals 2? Is that a max? Is that a min? Is that neither? At x equals -2, G prime was positive, then still positive, didn't change. Did we have to have a max? So G prime changes from positive to negative at x equals 2, which means G has a relative max at x equals 2. I want to make sure we get really, really good at free response questions like this. These are common questions. I just cannot emphasize enough how important it is that the writing is really solid. Any questions on part C? Gonzalo.
So if you were to write x equals -6, would you be able to ignore that, or like would it deduct point from you, or like?
If you write x equals -6, you're probably going to lose a point.
Even if you have the other ones correct?
Right, because what you're saying is you'd have to get the entire set correct to get that first point. If you include one that's not right, no good. You would get a point here, you'd get a point here, but you'd be throwing away this first point. Gonzalo, last question.
Does that mean you also lose the explanation points? Did you also explain that third one?
No, because the explanation points are separate from this.
Okay.
Everybody okay? Hopefully we're starting to get the hang of this. I know it's been a while with that 4-day weekend and core and all the other things. All right, so with that, see what you can do with part D. We'll talk in a minute or so.
Find all values. Which the graph has of G has a point of.
That's not yours, is it?
We have to find G rules, right? So make it like change the classes to negative.
That just means G has to have a max.
G of x is equal to f. So once you take, and once you get the derivative, you have to take the derivative. G double
Find all values of x in that open interval where g has a point of inflection. Alright, friends, want to pull this together. Floor, I think this one's coming your way. You got this. You're surrounded by brilliant women. You've got this. Floor. I want to find all values of x in the open interval where g has a point of inflection. How are you going to find a point of inflection?
Isn't it whenever the function is like changing from increasing to decreasing?
I want to be careful. G has the point of inflection. There is a function that changes from increasing to decreasing or decreasing to increasing, but to say the function is the problem because we've got G, we've got F. Which one are we talking about here when you say the function? You sure? You're right. If G has a point of inflection, this means that G prime, which we lovingly also know as F, changes from increasing to decreasing, or the change is from decreasing to increasing. G has the point of inflection. The derivative changes increasing to decreasing or decreasing to increasing. Paul?
Would it work if we said it has a relative max?
You could also say that G prime has a relative max or a relative min. That would work because to be a relative max, G prime changes increasing to decreasing. Relative min, decreasing to increasing. I hope at this point now it's easy. G prime changes from increasing to decreasing. Where?
X equals -4.
X equals -4, I agree. Anywhere else to change from increasing to decreasing?
X equals -2.
Wait, increasing to decreasing.
Yeah, it equals.
Right, look at the whole graph. X equals 0. The person who said X equals -2 is right, but it's not a change from increasing to decreasing. It's the change from decreasing to increasing. I want to make sure that you get that one. You get that one good. Otherwise, you're telling a lie. You're connecting things that are not true. Doing right? All right, now it's time for the push. It's the real big push. You've got this. Brace yourself for impact. Part F. Oh, do I love me some part F. We're going to skip over E. I want to see what you can do with part F. We'll talk a little bit. Yep.
So wait, you know how from the very beginning we said that G equals
I just know it's there.
G equals the interval?
The integral?
The integral,
Yeah.
and that equals f of x.
Yep.
Then how does G prime equal f?
Okay, hold on.
So what times we need?
G is the integral from -2 to x of f of t dt.
Yeah.
G prime is the derivative of that integral. And that's what's equal to f of x. It's not that G and f are the same. Those are completely different functions. But G's derivative is f. And that's this guy here, Henry. I know we keep coming back to this. This is the second fundamental theorem of calculus. There's more right there than there is wrong. I like that. H is the integral from -2 to 3 cosine pi x of f of t. Determine the equation of the tangent line. Now here's what I'm seeing on a lot of papers with S. I'm seeing a whole lot of folks that said, okay, I think this is what I'm supposed to do. 3 cosine pi x of f of t dt. How many guys have started this somewhere? Okay, now, if we're there, what is that? The derivative of the integral of this function from -2 to some crazy thing? It's the second fundamental theorem of calculus, but it's the extended version. So this is f of 3 cosine pi x, right? Plug the new function in, but don't stop, times the derivative of what's up here. And the derivative of 3 cosine pi x is -3 sine pi x times pi. Y times pi. Y times pi, Henry. Y times pi.
It's the stuff of the stuff.
It's the stuff of the stuff. It's the derivative of the stuff, right? Chain rule. This pi here is here because of the chain rule. Now, what I'm not seeing anybody do yet is, what is this? What is it that you're finding here?
H prime.
This is h prime of x. Now, I'm curious, though. Why are we even finding h prime? Axel's like, I don't know, but I wrote this on my paper because I'm pretty sure that's what I'm supposed to do. Sheila, why are we even taking a derivative here?
Okay, so it asks about the equation of a tangent line.
It asked about the equation of a tangent line, and you need a point, and you need a slope. Well done. So this is going to give you the slope. So h prime of 2 is, plug it in, f of 3 times cosine of 2 pi, yes I mean, times -3 sine of 2 pi times pi. Anybody know cosine of 2 pi?
Zero.
No, it's 1.
Cosine of 2 pi is 1. So this is f of 3. Anybody know the sine of 2 pi?
0.
0.
Yeah.
So you've got -3 times 0 times pi. What is that? That's all 0. Whatever f of 3 is, I don't care. If you say pi, I will come over and I will just embarrass you. Okay, so here's the thing. That's the slope. Where's the point? The point is what you get from actually finding h of 2. You're going to have to plug 2 into h, and so that's going to be an integral from -2 to 3 cosine of 2 pi f of t dt. To figure out that number, this is where you go back and you say, oh, how do I find the integral from -2 to 3 cosine of 2 pi? Area. It's an area calculation. Okay, we're going to do another one like this tomorrow. We're going to spend some, you're welcome, we're going to spend some time working on those multiple choice corrections to the quiz. United homework is assignment 102. Get it done, get it done, get it done. See you later.